it. I am a metabolic scientist. I'm the head of the Metabolism Research Lab at a university just south of here, about 30 miles. And I have a whole group of, a whole team, and we're constantly studying various projects. It is all relevant to metabolic health. In particular, we focus on this little, rarely talked about hormone called insulin. Now, it's gratifying for me to have people around here talking about it more and more, and I hope by the end of this, you'll be even more comfortable talking about it. So, insulin is what dictates how the body uses fuel. So let's get into that. Now, when I talk about fuel, before I mention that, it's helpful to look at the body in the context of there's a fire inside of it. That is our metabolism. When we talk about metabolism, people like to throw that word around. It is essentially the sum of all chemical reactions happening in our body at any moment. That is metabolism. And it does indeed create heat. We are warm-blooded because of all of these countless chemical reactions that are occurring. So if there is a heat, if there's a little fire, if you will, a chemical fire, there has to be a fuel that provides some of the actual material to be, well, combusted, metabolically speaking. These are what we commonly refer to as the fuels. They are also known as, very accurately, the macronutrients. Macro just means they're the big parts of our diet. They're the parts that constitute the bulk, the vast majority of what we eat. Now, I'm mentioning these as the metabolic fuel, but in reality, overwhelmingly, only two of these are actual commonly used fuels in the body, carbohydrate and fat. But I have protein there because it can be used as a fuel, and at the risk of getting way off topic, protein is only used as a fuel in states of genuine starvation, when someone has burned through all of their body fat in particular, which does not happen very often, especially nowadays. So rather than looking at protein as a fuel, let's look at protein as a building block. It does indeed provide the substance that goes in to help build our cells, to help build proteins, to help build our mitochondria, the parts of the cell where we actually burn the fuel for energy. So because we're looking at protein as a building block and not a fuel, I want to take it away for now and just focus on the two fuels. We are constantly burning these two macronutrients to just fuel our being, our living. The cost of living comes at the expense of burning carbohydrate or fat. Now, we're burning different levels of these fuels at any moment. And what determines the fuel we use is largely a matter, almost exclusively, there's some fine-tuning, but it's overwhelmingly a matter of insulin. Insulin dictates which fuel we use. It controls the lever of energy use in the body. Now, if insulin is the main driver of fuel use, the next question is, well then, how do we change insulin levels? How can we control our insulin, keeping it up or down? And I'll get into the relevance of that in just a minute. So let's look at what the macronutrients do when we eat them. What do they do to the insulin levels in our bodies? I can tell you everything I've learned as a scientist from the time of my PhD, throughout my postdoctoral fellowship, and now maintaining my own lab. Everything I've learned can be summed up in one simple concept. I personally, and with my family in mind, want to live my life, eat a diet that helps keep my insulin as low as possible at any moment. For every reason, some of which I'll get into in just a moment. So it matters to me what the food I eat does to insulin levels. I want it to matter to you too. If someone eats pure carbohydrate, this would be generally in the form of something like bread or any grain, cereal-like grain. Insulin will go up, depending on the person, about 10 times over where it was, which is substantial, and then it will stay high for up to 4 hours, again depending on the person. If someone eats pure fat, in contrast, well, there's nothing. There's no detectable significant change in insulin. And this has been done, of course. This is based on human data. If we have someone, we measure their insulin levels at time point 0, and then we give them a pure bolus of just pure fat, say coconut oil, for example, and we keep frequently sampling the blood over the next 4 hours, insulin just hums along. It didn't know anything happened. Now, just for the sake of being thorough, let's put protein back in, because protein is extremely important. If someone eats pure protein, like in the form of whey, say from Quadplex, there can be a modest increase in insulin, and that depends on the overall metabolic milieu of the individual. So there's a few variables that go into play there, but it's sufficient to say there's a mild to moderate increase in insulin. It can essentially be nothing as well, depending on the person. So getting back to fuel, and really getting to the meat of the matter now, we have the two metabolic fuels that we're burning at all moments. Whether we're sleeping, whether we're exercising, it doesn't matter. We're always burning some ratio of those two fuels. And again, insulin is the main driver. Specifically, if insulin is elevated, we are in carbohydrate or sugar burning mode. Blood sugar is commonly what we'll refer to as the glucose flowing through the carbohydrate form as it's in our blood glucose or blood sugar. So we're sugar burning if insulin is high. In contrast, if insulin is low through fasting or through being smart about the food you're eating or because you're sleeping, and I'll get to that point in a moment as well, then fat burning becomes a more predominant source of fuel for the metabolic engine. Now, speaking of engine, there's an analogy that I like to use, and it is thinking of our bodies as a fuel tanker. Doesn't matter what country you're in, you can find some sort of fuel tanker lumbering down the road. Now, on this fuel tanker, where is the fuel source for this truck? And of course, if you're being cautious, you're not looking at Instagram or Facebook like my students always do, you'll see that there are in fact two fuel sources here, right? Can you see the two fuel tanks? We have the little small one, and then we have the big one. Now, the great tragedy of this situation is, which of these two fuel sources actually fuels this truck? Small. It's the small one, right? And that's of course deeply problematic, because if we carry this analogy to the human machine, that small little fuel reservoir is comparable to our carbohydrate storage. And then in contrast, of course, that massive fuel tank on the back is comparable to, even in a lean, healthy person, it's comparable to the fat that we have stored on our bodies. That is what fat is. It is simply storing energy. It's essentially as if we were filling up that little small fuel tank on the bottom of the truck, and then as we fill it up too much, well, now it starts spilling over into that big tank. Okay, so in this engine in the truck, it of course is literally combusting. Indeed, it's not that far different from what we're doing as we're combusting fuel in our cells. So the engine is the action site on this truck. If we start to kind of blur the lines of this metaphor to the human, if insulin is high, what is fueling that engine? Yeah, it's carbs. That engine is sugar burning. Now, of course, the great tragedy is that little engine, every 3 or 4 hours on that truck, they have to stop and fill up, right? But how ironic that it is spending so much energy hauling around fuel that it cannot tap into. That truck's engine cannot tap into that big tank. In part, in this situation, because analogous to the human body, if our insulin is high and we start getting low on carbohydrate, you would think, well, let's just start tapping into our fat. You cannot do that. You cannot shift to fat burning mode if insulin is elevated. It doesn't work. The metabolic engine in the human body will not allow that shift. Now, if insulin is low, now we shift the metabolic fuel source, and now we're fat burning. That must happen for this machine to switch its fuel source, and the same thing, of course, goes for the human body. If we want to replumb our fuel lines to tap into all this energy that we're storing and carrying around, we're spending energy to carry energy, for heaven's sakes, we want to tap into that. It's somewhat silly for me when I hear people, they're talking about going on a 4-hour hike. Well, I need to take some energy bars. You have energy bars strapped to your body, for heaven's sakes. All you need to do is be able to shift your metabolic source so that you can actually tap into that energy bar. That's what you're carrying around, so use it. So now let me kind of quit mixing these metaphors and go straight back to the human body. Indeed, I know nothing about mechanics. I know the human body. So here we have a ratio of fuel sources in the human body. Indeed, it's actually not close at all to that same ratio. In our bodies, in the average individual, there's roughly 2,000 calories stored as carbohydrate. That's the total sum of all glucose in the blood, in the liver, and in the skeletal muscle. We have 100 times more energy stored, even in a lean person, as fat. So fat is an energy depot. Again, 100 times more energy stored as fat on our bodies. So this is where most people are today. They have a lot of fat stored, a lot of energy stored as fat, I should say. They're sugar burning all the time, and because of that, they have excess fat on their bodies. Now, what we want to do, if we can lower insulin, we shift that metabolic fuel source, and now we start burning fat. Of course, as we start burning fat, what starts to happen to the stored mass that we have as fat? That, of course, starts to diminish. So we use the body fat, and that, of course, means we have less and less of it day after day. Now, in contrast, if we stop doing what we're doing, we increase our insulin because we break a fast, we break it poorly, or like even for example, what happens every morning when we break fast with whatever the first meal is that we eat. Or we start going from a smart diet to one that is less well controlled. Insulin spikes, we stop burning fat, and we immediately shift the fuel source back to carbohydrate. And of course, as this continues, and we cannot use our own fat for fuel, we start to have excess. We're carrying around that extra fuel because we aren't tapping into it. We're not using it. Just like in that truck analogy where the truck constantly has to stop every couple hours, every few hours it has to stop and fill back up. That is why we have so many people, they'll eat some starchy, sugary breakfast at 7 or 8 o'clock in the morning. 2 hours later, around the time insulin's starting to come down, blood glucose has come back down, they sense that. In fact, you can have something called rebound hypoglycemia, where someone's eaten something very starchy and sugary, their blood glucose goes up really high, and then it goes below normal as it starts to level back out. When it goes below normal, 3 hours or so after someone eats, if that person is essentially addicted to sugar burning, if their body only knows how to burn sugar because of this so-called metabolic inflexibility, it can't shift to burning fat, if they're stuck in sugar burning, and the sugar just starts to dip a little below where they're used to, they start to sense this panic almost. I need to eat. It's silly. You don't need to eat. You have hundreds of thousands of calories stored on your body. But they sense this need because even though they're swimming in a sea of fat, they can't grab onto it and use it. So, if you are a sugar burner, you're almost addicted. You have to constantly be filling up the engine. You've got to eat 6 meals a day, or you feel like you do. And of course, the reality is far, far from it. Eating 6 meals a day is one of the worst things. It is to tell someone. The reason people tell type 2 diabetics to eat 6 meals a day is because it is a wonderful way to ensure the type 2 diabetic has to keep taking insulin forever. So it's wonderful for those people who sell insulin. All right, so let's switch the paradigm back to where we want to be, which is low insulin, we're lean, we're fat burning. Now, one thing, I don't mean for this to be upsetting, and I'm prepared to talk about this sort of thing all day. If fat metabolism, or catabolism, I should say, to be more accurate, if we are burning fat, breaking down fat over time for a long period of time because insulin is now almost chronically low, if insulin is chronically low, we get into such an exaggerated state of fat mobilization. We're basically opening up the doors of the fat cells so the fat cells can share their fat most predominantly with the muscle. We start to burn so much fat that we actually start creating these extra molecules that are derived from fat called ketones. Every one of you have heard of ketones. My lab is actively studying ketones. We're looking at the effects of ketones on the brain. We're looking at I'll show you some of the data, looking at the effects of ketones on fat metabolism, what it does to your fat, what it does to muscle health. Ketones are really remarkably beneficial molecules that have received a terribly unfortunate reputation. But nevertheless, ketones, what I would want you to know, if you have to address questions about ketones, you would simply say, ketones are evidence of high fat burning. That's all it is. A ketone is when you burn so much fat, it's basically like the exhaust from burning fat. It is a byproduct. It's coming off of the fat. You're burning more fat than you need to be burning if insulin is low, and some of that excess, if you will, starts to turn into these things called ketones. And some of you might have already become familiar with this, or you might even be sort of getting into that state of having ketones detectable in your blood. Most people have insulin that is so high, so chronically, that they never have any ketones in their blood. That becomes a problem, but that's a topic beside the point. So the ketones are very beneficial throughout the body. Now let's zoom into the body a little deeper. One of my favorite organs in the body is the liver. It's unfortunate here in the West we refer to our loved ones as our sweethearts. But in old cultures throughout the Middle East, they would refer to their loved ones as their liver. You're my golden liver. And I think that's more accurate, actually. And so the first time I said that to my wife, she was quite curious, but not surprised because she stopped really being surprised by anything I said years ago.
Chopped liver.
Yeah, chopped liver, yeah. Well, we talk about that as just a bad thing. Of course, that's a wonderful thing. So here's the liver. The liver is the site of action when it comes to ketones. So here we have insulin. One thing I want you to remember about insulin is that it dictates the fuel we use. Okay? So if insulin is elevated, so let me mention another metabolic intersection. We have this molecule called acetyl-CoA. This is getting a little more deeper than you'd need, but I wanted you to know where ketones come from. When we talk about burning fat and burning glucose, they actually are very different molecules that use very different metabolic pathways or processes, but they actually converge on one molecule, and that's called acetyl-CoA. That's why I refer to it as this metabolic intersection or branch point. It doesn't matter which fuel we're burning, it will converge at this molecule acetyl-CoA. So acetyl-CoA is this branch point of essentially every nutrient reaction. If insulin is high, insulin will tell the liver, take acetyl-CoA and turn it into fat. That is why you can have someone who eats nothing but sugar and starch, zero fat, and the liver, and yet you pull their blood and you see their blood is loaded with this type of fat called triglycerides. It's because of that process. If they're eating foods that increase their insulin, the liver is taking the glucose, it's burning it down to acetyl-CoA, and the liver is exquisitely capable at turning that glucose into fat. And we see that fat in the blood. And of course, once it's in the blood, it can go right to the fat tissue, which is why you can get very fat eating just non-fat at all, zero fat. All right, so nevertheless, that was a bit of a tangent, and thank you for humoring me. So if insulin is elevated, it's driving this push of acetyl-CoA into fat production. In contrast, if insulin is down, well, then there's two fates of acetyl-CoA. One fate will be that we actually send it into the mitochondria, the so-called powerhouse of the cell, and we burn it. We say burn because you actually do need oxygen to be there, just like you do when you're feeding a flame. So we burn the acetyl-CoA and we get energy. Chemical energy. The muscle can work, the heart can work, we can breathe, our nerves are working, we're moving electrolytes in and out so the neurons and nerves can work. So if insulin is low, we will break down the acetyl-CoA for energy. At the same time, some of that's going to be diverted into the production of ketones, a process called ketogenesis. Insulin is the key to ketogenesis. The only reason I study ketones is because of their connection to insulin. Because you, I hope, will start using insulin and insulin resistance and insulin sensitivity will become more and more a part of your vocabulary as you talk to people. It's helpful for you to know ketones are a part of that conversation. And you don't need to be shy about that. Ketones are produced if insulin is low. The ketones are produced because if insulin is low, fat burning is very, very high. All right, so pardon that metabolic tangent, if you will. So let's get back into ketones just for a minute, because I do want you to have a basal appreciation of them. There is a study published in Humans that took people with early stage Alzheimer's disease. It was 11 individuals. They'd had to quit their jobs or be reassigned at work because of how rapidly progressing the dementia was. This individual, the scientific team, took them, and one of the most pronounced focuses was to lower insulin below a very specific level, 6 microunits, and part of that was the motivation was to get them into ketosis. At the end of this study period, every single person was able to go back to work. They reversed, it was called a reversal of cognitive decline. In fact, that was the name of the study. Ketones are a very big part of that. Again, we're studying the effects of ketones on the brain in my lab right now, looking at learning. The heart actually beats more efficiently when it's allowed to consume ketones for energy. I mean, every time the heart contracts, boom, it's moving more blood than it was before if it's not fueled with ketones. Muscle starts to work better, and I'll come back to that in a moment. Inflammation goes down. This is one of the key aspects of ketones. It basically turns off this main key circuit breaker. So I've been rewiring my house. We moved back into an older home, just recently, and we wanted to change all the outlets and all the light switches. In order for those light switches and outlets to be turned off, I had to go out to the circuit breaker and turn that circuit off. That's what inflammation is. That's what ketones are doing to inflammation. They're turning off the circuit breaker. So any of those other genes that are relevant to promoting inflammation, they're also turned off. So ketones elicit a systemic reduction in inflammation. It's turning inflammation off throughout the body. And then lastly, body fat. Ketones elicit a very pronounced change in body fat, the way our fat cells actually behave metabolically. And I'll come back to that idea in a moment, just because it's so cool. Now, I've said this before, but not to you guys. When I first got involved with Unicity on the scientific advisory board exclusively about 3 years ago, it was just when Unimate had been released. It has quickly become my favorite product, partly because of the experiments that I'm doing in my lab with my research team, and we're learning more and more about Unimate all the time. One thing I want you to know about Unimate, and I don't mean for the conversation to dwell on this too long, Unimate is enriched with chlorogenic acids, which you've all heard about. You don't, I don't think, quite appreciate just what chlorogenic acids do. Just with this conversation in mind, and I will avoid the temptation to get off on a tangent, it has been published in previous labs that chlorogenic acids actually enhance fat burning by 24%. That's a pretty substantial increase in just the rate at which the cells are burning fat. Chlorogenic acids, I can't help myself, I'm going to tell you anyway. They also turn on an enzyme regulator, a protein regulator called PPAR-alpha. PPAR-alpha is like the circuit breaker for all these metabolic genes. When you turn that on, you're turning on a host of other genes that tell the body to start burning fat and to make more mitochondria to enable the body to be more metabolically flexible. So, just with this concept in mind, if you increase fat burning, you increase the production of ketones. And we have seen this in humans when are given Unimate from a fasting level, a relative change over 30 minutes, prolonged up to 2 hours. Ketones climbed in these fasted individuals who were just given a dose of Unimate. They went up by roughly 20%, and by the end of it was roughly 75% increase in the level of ketones in the blood. So whether you want to discuss ketones or not will be up to you as you decide what aspects of these scientific principles become part of your story, but it can be. You don't need to shy away from them, from discussing ketones. As polarizing a topic as it can be sometimes, it shouldn't be. So nevertheless, the increase in ketones we're seeing here could be a result of the known boost in lipolysis or fat burning that comes from a load of basically a good source of chlorogenic acids. Now, like I said, I have done research on this in my lab, and I just want you to humor me for a second and allow me to show you some research that we did looking at the effects of ketones on muscle. Because, of course, we all want muscle. I am desperately trying to get more muscle all the time. My sisters always say that I'm the petite brother. Yeah, but I also have the best six-pack, so I guess there's a trade-off. 8 boys in my family. I resent that classification. Yeah, there are 13 kids in my family. Yeah, that's why I'm so loud. If I hadn't developed a very loud voice early on, at the end of our dinner table, I never would have been fed. I had to learn to project. Okay, here's our study that we published just last year. It was all these undergraduates that led the work. I only want you to focus on a couple aspects here. And indeed, I'm putting the interpretation there because you're not in a position to really appreciate what I'm showing you just based on the data alone. On that top figure, labeled figure number E, or not number, but figure E, what we find there is that the actual amount of energy the muscle can create when it's burning fuel is not changed. So it's as energetically efficient as it ever was. It's burning energy, and it's burning fuel and creating energy for the muscle. That's still working without any compromise. The bottom figure, we found that in this instance, the actual amount of oxidative stress being produced went down. So the muscles were burning energy, and it was cleaner. Because oxidative stress you can look at as a byproduct. It's kind of like the dirty exhaust coming out of the burning of the engine as it's burning fuel. We have less exhaust, again, if you will. And so the ketones are creating a cleaner burning fuel for the muscle. All right, and indeed, we have seen this in muscle when the muscle has been exposed to, the body has been exposed to Unimate. If you actually take out a piece of muscle and determine how much energy in the form of ATP, that's the main form of energy in the muscle, is it being produced? Well, we see that it goes up about 30 to 40% after the body has been exposed to Unimate or been fueled with Unimate. So that was a direct study from our lab. We hope to publish these results probably early next year, and indeed with a lot more that I'm not taking the time to show you. But speaking of Unimate and muscle, I have to mention my friend Zach Bitter. Zach Bitter just again broke his own record in the world record for running 100 miles faster than any other person on the planet. You'd never guess how he did it. And, well, you will, given the topic. But here he is. Here's Zach after the feat, acknowledging the role of Unimate. In fact, here is what he said about it. During the race, I used a pack of Unimate each hour, starting at hour 5, because he actually ended up running for, I think, 12. Darren, how, 12 hours straight. Can you guys imagine? 12 hours. So he started at hour 5. And in his words, it just gives him energy without going overboard. It's an energy that he feels like he can control. And that's certainly something I've felt as well. But I don't want to sound too much like I'm a salesman. I am not. I'm a scientist. And so what I'm showing you data. My hope, again, is that it becomes part of your story. But let me keep going. So here we get into more science, the Activate nutritional principles. It is these 4 simple concepts based on macronutrients, the 3 macronutrients, and then the timing of the macronutrients, of course. So these are the nutritional principles that you've seen before. Now, these are not new. It may seem like they're new because we gave birth to them within just the last couple years in an effort to really crystallize some of these concepts. But Unicity has been leaning on these concepts without it being stated as such for years, of course. The idea of controlling carbohydrates has been profoundly evident in Unicity's development and use of very high-quality fiber-based products. And these, of course, are very well documented to improve cardiometabolic risk factors, as indicated from blood markers and beyond. So controlling carbohydrates is nothing new. Even the concept of prioritizing protein, as clever as that sounds, Unicity has been focusing on that for some time as well. So these first 2 concepts fit very, very well within Unicity's history of products. Now, there is, of course, one last lingering figure who's resented being left out. And where then does this where do we have this role for fueling with fat? We live in a very deeply fat-phobic culture, don't we, right? We're afraid of eating fat. All products are fat-free or low-fat. And Colette will talk more about this in a little while. But I want to address some common misconceptions, fears that you may have. If I'm eating fat, won't I get fat? If I'm eating fat, won't that clog my arteries and kill me? Well, you'll see the answers. Now, this is the long history of scientists and individuals who have focused on the relevance of certain aspects of our diet. Even before we knew what insulin was, because that's what everything was leading to, we knew that you could change the diet, and they didn't know it at the time, by avoiding foods that would spike insulin, it was the key to losing body fat, to burning fat. Type 1 diabetes provides a very interesting example of this situation. You know that in type 1 diabetes, the person has lost the part of their pancreas, those cells that create insulin. They have 0 insulin. What we found 100 years ago, these are legends in the field of both metabolism, that's Francis Benedict, and then Elliot Joslin is a legend in the realm of endocrinology or insulin research. They knew that if you look at a type 1 diabetic, in the absence of insulin, their metabolic rate was roughly 20% higher than it should have been based just on their body size, because most of our metabolic rate is a function of how big we are, or small, in my case, unfortunately. All right, as my sisters always remind me. In fact, these are just the data from these type 1 diabetics that you could see along the bottom. They expected, given the size, these were the actual numbers. Their metabolic rate was roughly 2,000 calories per day. Then after they started insulin therapy, the metabolic rate went down by 300 calories per day, just by increasing their insulin. It wasn't changing their diet. They just simply gave them a bolus of insulin, and the metabolic rate just plummeted. Now, in fact, if we look at it in real time, and yes, this is a type 1 diabetic, so it's an extreme example, but I want you to imagine this happening to you every time you're eating a food that's spiking your insulin. You see this minute-by-minute drop in metabolic rate. That happens in humans. As insulin climbs, metabolic rate slows. Now, this might seem a little shocking of a picture. The next one will be even worse. This is a woman's midsection. And so we're looking at her upper thighs right here. Those are not her knees. They're below the picture. They're not tumors either. She is a type 1 diabetic. So what does she have to do every day? She has to give herself insulin shots. And we tell type 1 diabetics to rotate insulin injection sites. Do you know why? It's to prevent this from happening. This woman had been giving all of her insulin injections in those two spots her whole life. And so as the insulin was loaded in those sections, what did it tell the fat cells to do? Hey, stay big. In fact, get bigger, because nothing tells a fat cell to grow like insulin. It's miracle grow it's fertilizer for your fat cells. Now, here's a more shocking picture. This is a man's belly. This was published in a very preeminent biomedical journal, the New England Journal of Medicine, by a group in Europe, in Great Britain. And they referred to this as belly bottom syndrome because, of course, of how it looks. But you'll see that he's only been giving his insulin injections in those two sites flanking his belly button. And that has resulted in this exaggerated, odd fat growth. He's not fat up top. He's not fat below it. It's just right there, because that's where all of his insulin is going. Just think of that as basically going throughout the whole body. All right, let me skip this just for the sake of time. This was a study by my friend David Ludwig at Harvard University. He's actually coming out here in just a couple months. What you see, the legend is on the bottom. As people were shifting their macronutrients in a way to lower their insulin, the people who had the biggest insulin drop, that blue line along the top, had an increase in their metabolic rate of roughly 150 calories per day, higher than what it was before. The people who focused on high carbohydrate diet, in other words, spiking their insulin all the time, their metabolic rate dropped by 100 calories per day. And so you ended up getting this change, not because they were exercising more, nothing else was different except the foods they were eating. The metabolic rate was almost 300 calories a day different between these two groups. The one group that was controlling their insulin, the one group that was spiking their insulin. And another study here that found a more modest change where it was about 70 calories per day different, but it was highly statistically significant. So if you think about, I'm going to go exercise, I'm going to exercise for an hour and I'm going to burn 100 calories, boy, you could, sure, exercise, it's great, but you don't exercise to be lean. You exercise to be strong. You eat smart to be lean because you can be skinny and sick. You want to be, of course, thin and strong. So that's the combination of being smart about the food you eat and the exercise you're doing. All right, now let's look at body fat very briefly with these concepts in mind. This is from my own lab. We had humans come in that were either in ketosis by very strictly following these activate principles that I showed you earlier, or they're eating the conventional standard American diet. We measured the resting energy expenditure. That's why I have that little bubble around their heads, because that's where you measure this by tracking all their gas, the CO2 and the oxygen. And then we pulled a biopsy from their fat right by their belly button. We made numbed the area and made a little incision and popped out a little piece of fat. And we analyzed them, metabolically speaking. What we see here in that bottom right figure, these are unpublished results. We hope to submit these by the end of the year. If we look in that bottom right figure, what we see there is the black bar is lower by about half. That means the fat cell is actually burning energy just for the sake of energy burning. That's what these two figures are telling us. That the fat cell is actually being wasteful with its energy. But can you think of a better tissue to be wasteful with energy than the one that's loaded with it? That's a dream come true, right? Our fat cells, what we found is that the fat cell metabolic rate about doubles in people that have ketones flowing through their fat. And when we looked at metabolic rate, unfortunately, when we looked at the whole group, metabolic rate wasn't different. But, of course, I'm at a university, so I had two very distinct populations. I had sort of those of us that are over 40, then I had a bunch of 20-year-olds. And when I split that up based on that 40-year-old cutoff, older people have an increase in metabolic rate when they have ketones in their blood. And remember, if you want ketones, just control your insulin. So we found that the ketones were doubling the metabolic rate in fat tissue and resulting in a slight but statistically significant increase in metabolic rate in older people, older being that over 40, which is not that old, right? I can still do more pull-ups than every one of my students, for heaven's sakes. Okay, more data here. This study, very, very good study, they put people onto 3 diets. One up top was the classic Standard American low-fat diet, which is avoid fat, focus on grains, starchy fruits and vegetables. It doesn't matter as long as you're watching your fat and you're counting your calories. So it was a low-calorie, low-fat diet, the typical way people want to lose weight. I'm going to starve myself until I can't starve anymore, then I'm going to just go crazy and eat everything back. And then the second diet was a higher fat diet, kind of Mediterranean, whatever that means, and never take that with too much seriousness. Every single study that's published, they'll call a diet a Mediterranean diet, and it means whatever the scientists want it to mean. It doesn't mean anything. And I mean that quite seriously. People claim to know what it is, and it never is really reflected in the research. But nevertheless, that's what they're calling a Mediterranean diet. It was, again, a low-calorie diet. So you have to watch what you eat. You have to count your calories. Then the last group, it was basically the Unicity nutrition principles. It was controlling carbs, focusing on fat and protein, calorie unrestricted. Don't count your calories. Now, one thing it is noteworthy, they actually started at a very low carbohydrate amount, very controlling carbohydrates, and they increased it by 6 times over the course of the study. So they went up to 120 grams per day, which is actually remarkably liberal. Do you know why? You don't know why. I'm going to tell you. They did that because the people were losing too much weight too quickly. Isn't that terrible? The purist in me would say, you should have kept them on it so we could see what really happened. But they literally started adding the carbs back in because they were losing too much weight. It was kind of disrupting the whole study. Some people in the group 2 were seeing the people in group 3 and saying, hey, what the hell? I want to be in group 3. I want to be with those guys. So they actually stunted their weight loss. So what happens? Just kind of look at these boxes on the bottom, if you will. I'm interpreting what you see. So if they looked at inflammation in the body, inflammation dropped with the greatest degree of carbohydrate restriction. If we keep going, if we look at hormones that come from our fat tissue, which are very good, adiponectin and leptin, the least changes were in the group that was the low-fat group, the low-calorie, low-fat group. Next, if we look all across the bottom, fasting glucose, fasting insulin, which is my favorite, and then the HOMA-IR, that's an indicator of insulin resistance when you combine insulin and glucose, we see that the worst changes were in the low-fat group, across the board. And that's what we're told we should focus on. So, you will pardon me if I'm deeply cynical and skeptical when a government body wants to try to tell me what I should be eating, when I'm the scientist. And so I appreciate the position I'm putting you in. I really do. In a way, I'm asking you to challenge the dogma surrounding nutrition. And these Unicity Activate nutritional principles, they force you to challenge that dogma. That can be uncomfortable. But it doesn't change the truth behind it. And I'm not done showing you truth. This was a study that took people into 2 groups. One was the classic low-fat, low-calorie group. Watch your fat and count your calories. The other was following the Activate principles and calorie unrestricted. Eat as much as you want. You don't have to be hungry. Just follow these principles of macronutrients. And if you look at that bold red line on the far side, if they look at actual fat changes, it was the calorie unrestricted group lost almost 5 kilos of fat versus 2 kilos in the low-fat group. They lost more than double the amount of fat by eating as much as they wanted. They didn't have to starve themselves. They didn't have to have some small little destined to be hungry little plate, eat knowing I'm going to be starving in an hour, but I got to push the plate aside. No, they could eat until they were satisfied by focusing on macronutrients that helped control insulin. Okay, but guys, there are so many more studies. Indeed, let me just sum it up here. I am aware of precisely 58 randomized controlled trials that have been done in humans, where they've taken humans and split them into 2 compartments of diet based on fuel, carbohydrate, and fat. One group on the left, it's focusing on a lower carbohydrate diet, more fat, so helping the body use fat for fuel. On the other side, on the right side of this diagram, they're focusing more on the carbohydrate side. And of course, you burn what you eat, right? Meaning actually that you're not what you eat in a way, but nevertheless, now here's my legend at the bottom. Just simply showing greater weight loss versus statistically greater weight loss. Okay, can you appreciate the difference? If it's not statistically significant, according to scientists, it didn't happen. There was nothing, it was just there was no meaning behind it. So, out of these 58 studies, 48 have shown generally greater weight loss by following the Unicity principles, like controlling carbohydrates and fueling with fat and prioritizing protein. On the other side, there have been exactly 7 studies showing greater weight loss there. But if we look at what was actually statistically significant, 29 are statistically significant in favor of being careful on controlling carbohydrates. 0, not a single study has ever shown statistically significantly greater weight loss on the realm of watch your fat, don't fuel with fat, and count your calories. 0. And yet that has become the bedrock principle. Every medical practitioner will tell you, any patient who struggles with weight, they'll say, oh, you need to eat less and exercise more. Do you know what is the perfect way to ensure you are as hungry as possible all the time? Really. Imagine, if you will, for a moment, I have the world's most famous chefs coming to my home. They're going to prepare a buffet of the most delicious foods you could possibly eat. And I invite you and I say, bring your appetite. I bet there are 2 things you're going to do to make sure you come as hungry as possible. You're going to be skipping meals and you're going to be exercising a lot. Can you see the problem? When we're telling someone what they need to do to lose weight, we tell them, skip your meals and exercise more. All we're doing is creating this unavoidable collision with appetite. Hunger. Hunger always wins. So, do you guys know the game show, The Greatest Loser? Have you ever seen the reunion tour? They don't do it because they gain it all back. They do. And indeed, they do irreparable damage. Their metabolic function actually never really recovers. This has been documented. They do such damage to their metabolic rate. Normally, if you're a big person, you have a high metabolic rate. As you start to lose weight, your metabolic rate comes down because there's less of you. And if you start to gain weight back, what happens to metabolic rate? It goes back up. Not in these people. They lost this incredible amount of weight through incredible starvation and exercise. Metabolic rate plummeted. They gained it all back. What happened to metabolic rate? It stayed down. It didn't recover. They've broken their metabolic function by following conventional medical wisdom. Eat less, exercise more. Well, to hell with that. The data don't support it. And then there are 3 studies that just fall in the middle, no significant changes on one side or the other. So that's the sum of all knowledge. And that is why I say what I do with such conviction. Because when people want to be a detractor and tell me I'm not showing truth, I say, prove me wrong. Show me the data. Because here are a couple dozen studies to support my agenda, my motivation, my perspective. If you believe it's wrong, then you can take up that as well. People will say, oh, well, in fact, quit distracting me. Okay. This one is a very sobering study. They found that if you take little kids and you measure their insulin, even if they're the same body weight, you measure their insulin when they're kids, the kids that had the highest levels of insulin, when they followed them up as adults, they were 36 times more likely to be obese than the kids who had normal insulin. And so when you are looking at your loved ones, when I look at my little 3 babies whom I adore and love more than anything, except their mom, I'm thinking about, what am I doing to your insulin? What am I doing to help ensure you have the best, healthiest, lean, I hope, future ahead of you? I wonder, what is the food doing to your insulin levels? We need to be cognizant of that reality. When we are spiking little kids' insulin to the highest quartile of insulin among little kids, even if they look lean at the time, 36 times more likely. You don't see those kinds of risk factors in human studies. It's extremely unlikely to see a 36-fold increase in risk. But it doesn't change the reality. All right, so here we are. Back at this image I showed you earlier, this paradigm of what do the macronutrients do to insulin. When we look at this in the average individual, and we're still talking about when I get fat if I eat fat. Remember, that's still the question we're addressing. This is, in fact, not the average individual. Why is this person not? They're not average because they're only eating 3 times a day. That's ridiculous nowadays, right? So we have these little, because most people eat 6 times a day, we have these little periods of fat burning. And when they wake up in the morning, why is fat burning a little higher? Because they've been fasting all night. Even if they didn't want to, they wake up and they're starving because they're so addicted to sugar burning mode. But they're burning a little more fat because insulin has been lower throughout the night. But of course, they immediately stop the fat burning with this sugary, starchy breakfast. Then right as insulin's coming down, they start to fat burn again, and then they bump up the insulin again. Then right as it's coming down, they bump up the insulin again. It's this never-ending cycle. Every waking moment is essentially spent in sugar burning mode. But if the person were eating this 4-4-12 concept, which fits into this intermittent fasting regimen that is part of the initially activate principles, they do have those brief moments of fat burning. Now, let's just say, heaven forbid, this is an individual who challenges dietary dogma and rather lets data make their decisions. We see that if they shift out breakfast as being such a starch, sugary, heavy breakfast and focus on the two parts of the human diet that you actually need, how's that for controversial? But I mean it. There are such things as essential fats. There are such things as essential amino acids or parts of proteins. Can you think of an essential carbohydrate? They don't exist. So why focus on that one? I'm not saying don't eat them. In fact, the closest you could come actually to saying there's some essential carbohydrate would be fiber, but it doesn't really fit anyway. It's its own thing. All right, but let's just say, quit distracting me. Let's say they focus on fat and protein. Then what had happened in the morning, that higher degree of fat burning that was evident when they first woke up, well, we fanned the fat burning flames. We've allowed their fat burning to get more exaggerated as we've allowed insulin to stay low. Fat burning just keeps ramping up. And then they have a little bump because they have a carb lunch, and then the fat burning can come back anyway. But if they just change that one meal, look at what can happen. Now, heaven forbid, let's say they change, Jesus, isn't it mind-blowing? They focus on essential macronutrients for 2 meals of the day. And of course, the same thing goes if the person's intermittent fasting, which you're all getting more familiar with if you're not totally familiar with it already. But what happens is that low level of insulin that's evident in the morning stays low essentially all day, right up until the dinner. And you know what? This is me. In my life, I am predominantly fat burning because of this scheme I follow. Whether it's through fasting through a meal or I'm focusing on fats and proteins for breakfast and lunch, I eat a normal dinner with my family. Whatever the family dinner is, now my wife is pretty much on board with all this anyway, so the dinners in my family tend to adhere to the activate principles, thank heavens. But if my wife weren't on board, it'd be a hard battle, right? I'd have to be a little more, careful in how I'm doing it. But this to me is a very practical way of doing it, frankly. And even still, there's a bit of a hack here. That insulin spike you see if I'm having a normal, somewhat kind of carb-heavy dinner. And for example, my 12-year-old, as a part of her church class, she needed to make dinner for the family, and she really wanted to make French toast. I try to be a very good dad. Imagine if I came home and said, "Oh, sweetheart, Daddy can't eat that." In fact, one time she made something and I said, "Oh, that's kind of high in sugar." She made some macaroons with my wife. Delicious. They went to a little baking class. She came home, "Dad, I made some macaroons." And I thought, "Oh, geez, sweetheart, nah, it has sugar. Daddy's want to eat it." And she looked up at my wife with this just broken-hearted face. "See, I told you Dad wouldn't eat it." And I thought to myself, Ben Bikman, you are a dick. You are going to eat your daughter's macaroons right now. And so I see her little face and I said, "Oh, sweetheart, what was I thinking? These look way too delicious." And I didn't regret it for a moment. So my point being, at the risk of you seeing too much insight into the Bikman family inner workings, you have to be pragmatic about it. And like I said, you can still have that kind of indulgence because unicity has provided a bit of a solution to the problem. You can sort of preload the system. And if you know you're going to be loading your system with glucose, you can mitigate the sugar burning shift by incorporating some fiber that we know for a fact changes the digestion sufficiently to keep the insulin and the glucose response less than what it would be otherwise. So that would have been my insulin spike with those delicious macaroons that my beautiful little daughter made, but I was able to mitigate it somewhat with a bit of therapy on the fly. All right, so with this paradigm in mind, won't eating fat make me fat? There is a resounding answer to that question, and it is no. You are not what you eat. Eating fat helps your body be in a position to use fat for fuel. It's training, it's putting in place the metabolic machinery to address that problem. Now, I need to pick up the pace a bit. Now, clogging arteries. I'm going to, at the risk of getting too deep, here is the most scientifically supported theory as to how we develop plaques in our blood vessels. Because if you are afraid of a heart attack or stroke, it's because you are in fact afraid of what's called atherosclerotic plaque formation or atherogenesis. This is the process of creating this lumpy little thing in our blood vessel that would grow to the point that it blocks the blood vessel to the heart, starving the heart of blood, and then a part of the heart dies. That is the myocardial infarction, aka heart attack. So you probably already know that aspect, but I want you to appreciate that process that I've outlined there. So we have this process of lipid accumulation. It can be in the form of cholesterol or individual fat molecules that we call fatty acids. Those can accumulate in the blood vessel wall. But mind you, they accumulate everywhere. They're fundamental parts of every single cell in our body. You have to have cholesterol and fatty acids coming into cells, or the cell cannot exist. It is physically made of those molecules. That is the majority of what is actually making the membrane or the wall of the cell. So that in and of itself is not a problem whatsoever. Now, so in fact, these lipoproteins, LDL, VLDL, are what's carrying these molecules. And you know LDL cholesterol, of course. It's gotten a very bad rap, but I won't get into that. Lipid oxidation. When these molecules, cholesterol and fatty acids, have been what's called oxidized through reactive oxygen species or oxidative stress, now they turn from benign into villains. They're no longer heroes. They're no longer beneficial to the cells. They are now overtly harming the cell. These are extremely, we call them radical. They're damaging. These are very damaging, very dangerous molecules. These lipid peroxides, or these oxidized lipids. Now what happens, because these molecules are so dangerous, the body has a way to try to get rid of them. And so we have this immune cell, the macrophage, or monocyte, as it's known as it's flowing through the blood, comes to save the day. The monocyte will move into the blood vessel wall and start gobbling up those lipid peroxides, or those villainous lipids. Remember, they're only villainous because they become oxidized. Now that macrophage is loaded with fat. It becomes what's called a lipid-laden macrophage, and it becomes a foam cell, because when you look at it under a microscope, it looks foamy. Looks like it has little bubbles of air, but they're bubbles of fat. It's those fats. So then the foam cells start to accumulate. They are very pro-inflammatory, so they start releasing proteins that increase inflammation throughout the body. And then these proteins actually start to call more macrophages to come. So we have this accumulation of these very inflammatory foam cells, and this becomes the heart of the atherosclerotic plaque. There, now you know. In fact, now you know more than many conventional medical practitioners, actually. I mean that, in all sincerity. This is the most scientifically validated or justified theory for how we get a plaque forming. So this plaque is at the heart of heart disease, heart attacks. Now, of all of this process, what was so essential was the formation of the lipid peroxides, or the oxidation of the lipids. If that doesn't happen, we don't start the process. I hope, is this getting too boring?
No.
You guys still here? Okay, good. I need to, it seems like you're paying attention just because you're not staring at your phones.
How does your wife do this?
Yeah, mind you, this is not pillow talk in the Bikman home. Things can get a little more exciting. Okay. Shh. Come on, we're all grown-ups here. Yeah, this is sexy, she says, yeah. That's how I got my wife to marry me. I said, sweetheart, I'm going to be bald in a year from now, but I got a beautiful brain. You just got to take my word for it. Okay, I actually had more in the marriage contract than that, but I'm already being a little moderately inappropriate, so I'll stop. So, all right, so we have to ask the question, if the lipid must be oxidized for it to be atherogenic, how does the lipid become oxidized? There are some lipids that are so prone to oxidation that the moment you open the bottle and expose them to oxygen in the atmosphere, they get oxidized. There are some that are so profoundly resistant to oxidation that you have to heat them to about 300 degrees Celsius before they can get oxidized. It is against its natural state. They're so stable. Now, as I mentioned there, the more unsaturated bonds between the carbon molecules, and I'll get into this more, the more likely, the more prone it is to becoming a lipid peroxide, or a damaging, villainous lipid. So here I have two examples. Which one has more unsaturated bonds? And we identify that by a double bond. Which one, top or bottom? The bottom one. And in fact, that is the so-called vegetable oil. It's seed oil in reality, but things like soybean oil, cottonseed oil, what are some other ones? Canola, safflower, all from those little seeds, those industrial oils that they have to add deodorants to them at the chemical plants because they stink so horrifically as they get oxidized. You smell the rancid oils because they become rancid or oxidized extremely readily. In contrast, you take something like coconut oil. No, you have to heat the coconut oil up to a very, very high temperature until those bonds can become oxidized. This is very well established. This is very well documented. Talk to any chemist. I'm not a chemist, I'm a biochemist. They will tell you, in fact, as you scan the entirety of biomedical literature, if you look for polyunsaturated oxidation, you'll find thousands and thousands of articles. You try to find even one article that talks about oxidized products from saturated fats, nothing. It doesn't happen in normal biological conditions. So anyway, some of the science there, but I'll come back to that point in a minute. What I want to convey here is that we look at LDL as a villain, and I'm not going to get into this in too much detail, in fact, not beyond this. The fat that the LDL molecule is carrying, yes, it can carry some cholesterol, which is not a problem. You have to have cholesterol. How many people want more testosterone and estrogens? That comes from cholesterol. How many people want vitamin D? That comes from cholesterol. How many people want, you won't know this protein necessarily, but ubiquinone? It's a necessary part of the mitochondria. You can't burn fat without cholesterol. It is essential to human health. So, LDL is, yes, carrying cholesterol, but it's also carrying a lot of fats. Guess what makes up those fats? It's the fats that we eat. So if you're eating more, say, saturated fat from real sources like animal and fruit fats being coconuts, avocados, olives, those are fruits, they're not seeds, there's no vegetable fat. When anything that says vegetable oil, it's from seeds. That becomes, those saturated, very stable fats become part of the fat being carried throughout the body, indeed even on LDL. In contrast, if you're eating a lot of those artificial industrial oils, they become a part of your LDL, part of the fat traveling through the blood. And this matters because, as you'll see here, you look at the dietary fat sources in the US in the last 100 years, look what went from zero to main fat, soybean oil. 70 years ago, we didn't eat a single ounce of soybean oil. It has become the single most common source of fat in the Western diet. I say the Western diet, but in fact, it's even worse in countries like India, actually. And that's part of why I believe in India there's such a pandemic of diabetes. It's because of this focus on these seed oils, and in fact, very little omega-3. As an aside, I'm talking about what's called an omega-6 polyunsaturated fat. It's called linoleic acid. It's an omega-6. One of the ways to offset some of the damage that omega-6 linoleic acid can do is by eating a similar molecule, but that can't be used the same way, and that's omega-3. Omega-3 can combat or disrupt the body using that omega-6 in such damaging ways, and indeed, it can really only be damaging. But you see soybean oil, and what's the next one? Shortening. That's also based on seed oils, another omega-6 polyunsaturated fat. So the two most common sources of fat in this Western diet, that is now, of course, the global diet, are loaded with linoleic acid, which is this omega-6 fatty acid. And we always want to implicate beef and red meat. No, we don't eat any more red meat than we did 100 years ago. In fact, if you combine beef and pork, we eat less. So don't blame the red meat for what those oils are doing. All right, so linoleic acid. If we start to look a little beyond the conventional blood measurements that we get, yeah, we're going to get LDL from our physician, our doctor's visit, total cholesterol. We want to know what's on the LDL. What are the fats it's carrying? This study found that in this big analysis, dietary linoleic acid, that's that omega-6 polyunsaturated fat, was the most important determinant of the maximal oxidation velocity. So if they took LDL molecules and determined how rapidly can the fats on this molecule become oxidized, it was entirely dependent on how much linoleic acid the person was eating. This study, cholesterol as well as diets rich in saturated fat have been postulated to accelerate the risk of atherosclerosis, while food rich in unsaturated fats, like the seed oils, the linoleic acid, have been claimed to lower the risk. However, the fact is that these lipid radicals, what I'm talking about, these lipid peroxides or oxidized lipids, generated from polyunsaturated fats can oxidize cholesterol to toxic levels. And that would then, of course, drive the atherosclerotic plaque. And at the bottom, I love their conclusion. A serious reconsideration of the health and diet guidelines is required. No kidding. Yeah, and that's what we're doing. That's what we've done, indeed. All right, this is a neat study. I have to just mention it. In Sydney, the Sydney Diet Heart Study, they actually took a big cohort of people. They said, you keep eating what you're eating. You eat less saturated fat, which are real fats from animals and fruits that we as a species have been eating since time immemorial. They said, you eat less saturated fat and rather focus more on these seed oils. Guess what happened? They died more. Their all-cause mortality, meaning dying from anything, went up. Same with heart disease and cardiovascular disease. The great irony is we're telling people, well, not me, the powers that be are telling people, you got to eat these seed omega-6 polyunsaturated fat oils. And they're dying more, even from heart disease. This is not the only study. A huge study in the US about 50 years ago found the same thing. And there's another study called the Shanghai study that I won't show you, found the same thing. More stuff. For the sake of time, I'm just going to speed up. But in sum, when people want to try to vilify saturated fat, you say, show me the data. And you only want to look at clinical studies. You just want clinical studies. You don't want big epidemiological studies. But speaking of epidemiological studies, throughout Europe, there was something once called the French paradox. We don't understand. The French eat a lot of saturated fat, and yet they have almost no heart disease. It's not unique to France. In fact, if you look across all of Europe, there is this inverse relationship. The countries that ate the highest amount of saturated fat as a percent of their total fat calories had the lowest level of heart disease mortality. This study actually was an intervention. They took people and they said, look in that box that I've expanded there on the right, they told a group of people, you have to eat half of all of your calories from saturated fat. That's pretty remarkable. It basically became a diet consisting of cheese, meat, and eggs, which sounds pretty delicious, frankly. But what's their conclusion? This high saturated fat diet, again, half of all calories, which is pretty extreme. It resulted in weight loss after 6 weeks without any adverse effects on serum lipid levels. So all they did was lose weight and their blood lipids looked fine. Okay, so is it going to clog my arteries? The answer is absolutely not. And when you get challenged on that, I encourage you to say the most fundamental pathogenic aspect of the development of a plaque is the oxidization of the lipid. A lipid must be oxidized for it to be atherogenic. And the person can generally say, okay, that makes some sense, I guess. And then you say, well, what are the lipids that are the most oxidized? That's when the whole story starts to fall apart. And you can say that's why we can justify focusing on real ancestral fats rather than these new modern industrial oils. All right, so what I hope you remember as my time is wrapped up, I want you to just remember, well, I guess that previous slide with those questions on it, that you're not going to get fat from eating fat. You're not going to get fat, especially if it's encompassed in the Activate principles. You're not going to be clogging your arteries if you're eating fat and it's fitting within the context of the Activate principles. I want you to remember, we want to be fat burners. We want to be using the fat that our body is so well designed to store. And thank goodness that it can. Did you know there are genetic disorders where people can't store fat? It's called lipodystrophy. These are people that look exceedingly fit. They have no subcutaneous fat, so they have glorious six-packs. You see every striation in their muscles across their pecs. Even in women and across their deltoids, you see every ripple of the muscle. But because they cannot store extra energy in fat cells, they start to dump it into their muscles, they start to dump it in their liver, even in their bones. They are profoundly sick. So, lest you curse your body fat, you should indeed be grateful. We are designed, I mean it, the body is designed to have that reservoir of energy. It is a blessing that we can store energy. We just want to keep it in control. And if you want to be using that energy that your body is so inclined to store, you have to be following a lifestyle that keeps your insulin low. Otherwise, all you're doing is carrying it around, never actually getting any benefit from it. Thank you, guys. Your story that you can tell people. You understand the concept well enough, you can put it in your own words. Now, all of this is the science. And it has been I mean this, it has been my great pleasure to be tapped by Unicity, to help Unicity focus on the science. One of the problems with science is that all we do is we do experiments, and the most we can hope for is that we get results that are statistically significant, and we publish it in a paper, and no one ever knows. Even my own dad, my mom died when I was a little boy, so even my own dad doesn't care about me publishing papers. You know, it's not like I can say, Dad, I published another paper. No one cares. My wife couldn't care less. That is the life of a scientist. It's generally doing stuff no one cares about, and never actually making a difference. For Unicity to come and say, hey, this is good science, we want to try to actually bring this into practice, that is very gratifying for me. To be able to see something at the end of it, something tangible, something beneficial. Now,